So the next form of quadratic we're going to look at is called HK form. The A gives us the reflection if it's negative and a dilation factor, horizontal translation and a vertical translation. What's actually translating here is the turning point. It's moving horizontally or vertically by those particular units. When you're sketching a quadratic that's in HK form, you need to consider again the transformations that occur from the base function. Ask yourself the following questions. Is there a reflection? Is it negative or upside down? What's the general shape? Is there a dilation? Is it steeper or flatter? What is the vertex? It should be able to read off as HK. Notice the change in sign. The form of HK has a minus H, but the vertex is actually H units. What is the y-intercept? That is, what is the value when x is 0? And the vertex is often called the turning point as well. So here are some equations that we're going to have a look at and see what they sketch like. Again, axes, make sure they're labelled. Write the equation. Here we have x plus 1 all squared minus 2. Steps to consider are, what is the general shape? We look to see if there's a negative. It's positive. So we've got a positive quadratic. What is the vertex? We read straight off. It's going to be minus 1, minus 2. Opposite sign, same sign. The y-intercept, when x is 0, cover this up, we get 1 squared minus 2, which is minus 1. On your graph, mark on the vertex, mark on your y-intercept, get the general shape, and then you're done. Again, start with your axes, make sure they're labelled, draw the equation. Minus 2, x minus 3 all squared plus 1. General shape, we can see here that A is negative, so we've got an upside down quadratic. The turning point is opposite sign, same sign. So it's going to be 3 minus 1. In fact, there's an error here and I'll correct this in just a minute. So we're going to go with this one, 3 minus 1. Y-intercept, when x is 0, we get this intercept. Mark on our vertex on the graph. Mark on our y-intercept, draw in the general shape. Make sure that they're labelled either on the axes or you label the particular point. Yeah, there's my correction. On to another example here, axes and they're labelled. Draw the label of the graph, 100 x plus 85 all squared minus 78. This is just to show you that even though the numbers can get quite large, the process is still the same. Get your general shape. This one's positive, it's 100 x squared. The vertex we read off as the minus 85 minus 78. And the y-intercept, you cover up this and you think to yourself, well, what is it when x is 0? It's going to be 85 squared times 100 minus 78. So it's basically going to be very large positive. Start putting those things on the graph. You can see here, there's my vertex. My y-intercept, which is very large positive, is going to be way up there, but that's good. It was good information. It tells me that it crosses up here and not down here. Draw in the quadratic, make sure you've got a good shape, that it's not too pointy at the bottom. Another thing to note is that the roots of the equation are always equidistant from the vertex. So once you know that, the roots go on either side.